All right, we are going to do something now. This is Algebra 2, right? Yep, that we're going to talk about quite a bit through the rest of the chapter. Something that you probably, my guess is, you may not have seen before, okay? This is normally not a Algebra 1 topic. It's definitely not a geometry topic, all right? So this may be the first time that you've seen this, and probably the first time this year so far that we've actually done something that's Algebra 2 and not Algebra 1 review stuff. All right, so here we go. It's called special functions. All right. We have talked about a function, haven't we? Yes. Have we done, like f of x? Yes. Yeah. So let's talk about this function. This is kind of weird. This is a general word for this. It's called a piecewise function. Some of the stuff that we're going to do you may have seen before. I don't know. Let me see. Yeah, this is going to be pretty little different, okay? It's going to be a little different for you. Where are you going? Everybody's leaving my class. Is somebody still out? Denise is still out. Wait till she comes back. All right. Let's talk about the piecewise function. There is a definition for it. I'll just read it off. It says it's defined by different expressions for various intervals of its domain. You're like, what in the world does that mean? I would agree with you. If I just heard that, it wouldn't make any sense to me. But here's what we're going to do. We're actually going to put three different. Is it different graphs? Yeah, 3 different graphs on the same graph is basically what we're doing right now. All right, but the graphs are a little bit different than what you've seen before. So we're going to do 3 of them. We're going to go x plus 3. That's one thing we're going to graph, but they're going to give you some restrictions. We've talked about domain in here, haven't we? Yeah. Didn't you have a quiz on it, right? The domain? Yeah. So here's your domain or your restriction. Okay, x is restricted. I'm not just going to draw a line with a y-intercept of 3, a slope of 1, and just a continuous straight line. I am going to restrict it so x can only be the numbers that are less than -2. All right, so I'm going to graph x plus 3, but I'm going to restrict it. And then I'm going to do another graph, which is x squared. Have you ever graphed x squared before? I don't think we've graphed an x squared, have we? Seems kind of weird that they would put that here, but I'll show you how to do it. It's not that big of a deal. -2. Again, we're going to restrict the x. It's less than, oops, what am I doing? I already did that. It's less than x, which is less, that's what I wanted, +2. And then f of x equals 1 if 2 is less than x, which is less than or equal to 5. That's pretty crazy, isn't it? All right, let's put a graph here. Let's see what we can do with this mess. All right. First one shouldn't be all that bad. It says f of x or y equals, right? We've talked about that before. So y equals x plus 3. If I was to graph that just normally, we already mentioned it a minute ago, how would I graph that thing right there? Well, I go to 0, 3, right? So the y-intercept is 3, and what is the slope? Slope is what? 1, right, because there's a 1 in front of that, right? So y equals x plus 3. So you can go up 1 over 1, right? Down 1 to the left 1, right? Just keep on plotting these points. But here, I'm going to draw the whole entire line, even though we're not going to include that whole entire line. Let me see. It should look like that. Don't draw that. Don't draw it just yet, because that's not really what they ask for. Okay, that's this part of it, but they give you a restriction on the x's. Okay, what x's you're allowed to use. On this right here, if I put arrows on the both ends, that means my x's are all the real numbers. But in this situation, I'm restricting the x's. So x can only be what? Less than -2. So watch, I'm going to go here on my x-axis to -2. Now, where does it hit the line when x is -2? What's the y? It's 1, isn't it? But it says it's less than -2. So what kind of a am I going to put a closed-in circle here? No, I'm going to put an open circle here. So x can only be the numbers that are less than -2. You with me? So there's -2. I put it here. So I can only go to -3. I would go here. -4, I'd go here. -5 down here. -6 down here, and so forth. Everybody see that? Which of the part of the graph can you not include? All the stuff that's greater than -2, correct? So this is going to have to go to here. Does that make sense? So that's what this says right here. It's not an entire graph. And in fact, I put all these points on here. I can just get rid of those points because we're not going to include those anyway. And there, okay? So that is this part of the graph. So we've restricted the x's. My x's can only be from -2 to the left, all right? Less than -2. Somebody get that, please? Does that make any sense to you? All right. So that's how we do that part. Now we're gonna do two more. Tell you what, we'll save that x squared for the last, okay? Let's do this one right here. So what does this say? This says f of x equals 1 or y equals 1. We're used to seeing it like that. So just so you can see what that means. What does that mean? Y equals 1. Tell you what, I'm going to do that in a different color. It means it goes through the y-axis. It's a horizontal line, and it goes through the y-axis at 1. So you would be right. It would be at 0, 1. Okay? Everybody see that? So if we were just going to graph this, now it gives you some restrictions, doesn't it? But I'm going to graph it without the restrictions, and then I'll do what I did here. Okay? I'll look to see what the x's can be. So if I just graphed y equals 1, it would look like this. Agreed? All right. But what does this say, though? They give you some restrictions on it. They say that x can only be between what and what? 2 and 5. So what I'm going to do is I'm going to go over to the 2, then go up to where it hits the graph. Is it going to be a closed or open circle here? It's going to be open. Okay, if it doesn't say or equal to, it's going to be open. So again, I go over to 2 on the x. Where does that hit my graph? It hits right here, and that's going to be open. But then it also goes all the way to what? 5 on the x. 1, 2, 3, 4, 5. And you go up here. What kind of a circle do we have here? It's going to be closed. All right? Now, does the line keep extending forever? No. This graph can only include from here to here. So all the rest of it, I'm just going to move it in to there, and I'll move this one into there. So that is that third part of my graph. Make sense? Okay. And again, this is supposed to be closed in. I'll close it in a little bit better. There we go. All right, so that's that part. So it doesn't keep on going forever. It only goes between 2 and 5. 2 is open, 5 is closed, and it's just that stuff in between. All right, let's do an x squared. Before we graph it on here, let's talk about how to graph an x squared. Oops. Remember when you first learned how to graph, you did this thing? Yeah, okay. So let's put a few numbers in. Okay, let's go -2, -1, 0, 1, 2. Is that all right? Is that better? Okay. I'll push this up a little bit. So what if we're graphing x squared? So y equals x squared. What's this going to be? What's the y part going to be? Well, it's -2 what, though? No, it's -2 what? What are you doing to the x? You're squaring it. Okay, so it's not -4. It's positive 4 because it's negative 2 times negative 2. You're squaring the negative 2. So negative 2 times negative 2 is positive 4. You with me on that? Let's put a negative 1 in for x. It's positive 1. Put in a 0 in for x. 0. Put a positive 1 in for x. Put a 2 in for x. Positive 4. So this is what our graph's going to look like. Tell you what, I'll put a little graph down here. I just want you to see what a regular, if you want to call it, a regular y equals x squared graph looks like. Because we're going to restrict it here, aren't we? But I just want to show you what it's going to look like. Now this could keep going. I could have put a negative 3 and negative 4, couldn't I? I could keep on going when it's just y equals x squared. So let's see what that looks like. Negative 2, 4, 1, 2, 3, 4. Let's make that a color. Keep it green. Actually, I should make it a different color since I have green up here. That's all right. Negative 1, 1, negative 1, 1, 0, 0, 1, 1, and then 2, 4. You see that? It's a little small, but here I'll blow it up a little bit. Now, does that mean it's just a straight line from here to here? There's 4. Sometimes this thing doesn't make little circles very well. There we go. Okay. Watch what this does. This actually curves. Like if I connect here to here, it would go up like this, wouldn't it? Well, where's that going to be? Watch. It's a curve that looks like this. And it keeps on going like that. So that's what a y equals x squared graph looks like. Probably the first time you've ever graphed something with a curve like that. What is my guess? Is that true? Probably. Right? But that's what it looks like. It's got a nice smooth curve to it, and it keeps on going forever and ever. Watch, what if I put a 3 in there? Where would I be? I'd be up here at 9. 9 would be right there. See how it, well, I curved it a little bit too tight, but it would, anyway, it would go up like this. What if I put a 4? I'd go all the way up to what? 16, and so forth. Right? Make sense? So what we're going to do is we're going to do this graph. We're going to do it here. But we are restricted, though. Where are we restricted from or to? Let's change colors. Let's go blue. Look, here's our restriction. So I can only go from where? From negative 2 to positive 2. Correct? I mean, that's all I did on that little table anyway. All right, so that works out pretty good. But the thing is, it's not going to keep going with the arrows. It's going to stop wherever I hit the graph at negative 2, right here, and then wherever I hit the graph at negative 2 or positive 2, right there. Okay? So let's graph the thing. So I can pick any numbers between negative 2 and 2. And they're colored in, right? They're solid dots because of or equal. So at negative 2, where is x squared? It's at 4. 1, 2, 3, 4. And I can put a dot there. At negative 1, I go to positive 1. At 0, I go to 0. Positive 1, I go to positive 1. Positive 2, I go to positive 4. But it doesn't keep on going. It just stops right there. Everybody see that?
So when you went x squared, you only do negative 2, negative 1, 0, 1, 6?
You could do more. But in this situation, you can't do more because you're restricted. So you can only go from negative 2 to positive 2. Notice I didn't put an arrow here, did I? All right, because it stops. If it was just y equals or f of x equals x squared and it didn't give you any restrictions, then I would have kept on going and I put an arrow there on both of them. Does that make sense? But on this particular one, right, these are special functions and they restrict the domain. They restrict your x's, so you can only go from there to there. So this is your graph. It's basically 3 graphs in one, all right? It is continuous because look, it starts from here, it goes to here. This is open, so it doesn't include negative 2, but this blue one does include negative 2, doesn't it? All right? And then if I keep going, negative 1, 0, 1, 2, 3, 4, 5, watch. That keeps on going from here all the way to there. That hits negative 2, but then the next graph does not hit negative 2, but then it hits everything else. So what's your domain for that entire graph? Look, I hit every possible x. Remember, x is the domain, right? So I'm hitting every possible x value, and I can hit the graph, can't I? If I go all the way up to negative 100, I'm going to eventually come down and hit that graph. Okay, all the way until you get here, you're like, well, wait a minute, there's a gap here. But in the second part, it fills the gap, doesn't it? That fills your negative 2. Right here, negative 2 is not included, but here, negative 2 is included. So far, all the x's work from negative infinity all the way to here, all the way to here, right? We jump down and it goes to here. So it's not all the real numbers. What is it? It's from negative infinity, right, all the way till where? Where does it stop? At where? At 5, right. 1, 2, 3, 4, 5, at positive 5. So that's your domain from negative infinity all the way to 5. Or you could say x is everything that is less than or equal to what? Positive 5. That's another way to write the domain. Does that make sense? All right. So that's the kind of stuff that we're going to be doing. That's called a piecewise function, because there's another piecewise function that we're going to do. Well, we're going to do some more, but it's not until about halfway through this lesson. Yes. Where did I get the 5? What's in less than or equal? Where? Here? Less than or equal? Oh, this, infinity. There's two ways to write it. Okay, you could go all the way to negative infinity, right? Because negative infinity would be out here, correct? What would this be out here? Positive infinity, right? So this goes all the way to negative infinity, and it stops at 5. We use a bracket, like when you have less than or equal. A lot of times we use a bracket. There's two different ways to write the same thing. You probably haven't seen that before, but you're going to see it a little bit in Algebra 2, all right? Quite a bit in Algebra 2. It's usually about the first time you see this stuff, right? So this is one way to write this. What does this mean? It means it goes all the way to the left, right? X could be any number all the way to the left, but it stops at where? Positive 5. Doesn't that mean the same exact thing? Yeah. It stops at positive 5, but it means everything to the left. These two things mean the same exact thing. It's just two different ways to write it. Okay. Let's do some more. Let's grab this graph right here and copy it, because I'll probably use it again. Now, let's do this. Do they, let's see, anybody got their book open? You got your book open? Look at example 1. It says state the domain and range of each function. Do they actually graph it for you? Like 1A? They do put the graph there? Okay. And you just have to find the domain and range. All right, I was just making sure. All right, here's the graph they give you. So they give this to you. They put a point at negative 4, 5, 1, 2, 3, 4, 1, 2, 3, 4, 5. So they put a point right here. They put a point at negative 1, 2, negative 1, 2 right here, and then 3, 6. 1, 2, 3, 1, 2, 3, 4, 5, 6. Okay? So they give you this. This is in the book. They give you this graph, and what you have to do is tell what the domain and range of that graph actually is. And it stops right there. Again, this is negative 4, 5, negative 4, 5. This is negative 1, 2. And this is, what did I say it was? 3, 6, right? You with me? All right, so they give you this. All right, I didn't figure it out. They just put it in the problem. What I got to do is find the domain and range. Domain and range. Again, what is the domain? Say that again. Negative 1, 2. Yes, that's negative 1, 2. Negative 4, 5, 3, 6. All right? So where's the domain? I'm looking all along the x. Okay, is it all the real numbers? Does it keep on going all the way to the left and all the way to the right? No, we're restricted, right, between one point and another, just on the x's. Okay, the domain is just the x's. So how far over do I go on the x to the left? To -4, right. So I start at -4. Everybody agree? And it covers everything between -4 and what? No, not 6. 6 is not the domain. 3. Again, the x-axis, okay? How far over does it go? So it starts here and it ends here. So from -4 to what? To +3 and everything in between, right? So how do I show everything between -4 and -3 or +3? So x is between, and it includes those points. So what am I going to put here? Less than or equal to, and then what am I going to put here? X is less than or equal to 3. You see that? So -4 is less than all these, or you could look at it this way. X is greater than or equal to -4. And x is also less than or equal to +3. That's my domain. They always like to put the brace when they ask for the domain, so we'll do that. We also had a little fancier way to write this, didn't we? Do you remember that? Remember that such that thing? I wouldn't mark off if you didn't do it, but they're going to say the domain are all the x's such that x is between -4 and 3. It's just a little fancier, a little bit more proper way of writing it. I would put it, okay? You just got to get used to it. You got to at least get used to seeing it, because you're going to see it in here when you take pre-calc next year. You'll see this all the time. All right, you just got to know what it means. It just means all the x's such that x is between -4 and +3. What about the range? Now I'm not going to put x. What am I going to put? Y such that. Now let's do the same thing with the y's. What's the lowest y value? The lowest. It's 2. It's right here, isn't it? So it starts at 2, right? And where is the highest y value? It goes up to 6 right here. All right, so I'm going to put a 2 and a 6 here. So that means y is between 2 and 6. Again, how do I show y is between? Put less than or equal, close the brace, and then there's the range. Do you understand what we're trying to do for domain and range? All right, we're just trying to find out what x values are included in that graph for the domain, and then which y values are included in the graph for the range. And then we just write it down like this. Again, what does this basically mean? It just means x is between -4 and 3. All the x's can go from -4 to 3. They can't go bigger than 3. They can't go less than -4. All right, because that's not what's shown on my graph here. Got it? I missed a meeting today that I thought was tomorrow. This guy was waiting for me. He had a check to give me for a wedding that I shot. And he even said on the text tomorrow, and that was yesterday. But for some reason in my head, I was thinking tomorrow was Saturday. And I'm like, yeah, I can meet you at 9 o'clock. I put it on my calendar and everything. Then he texted me like at 10:30. He says, were you planning on coming by today? And I was like, today? And I looked at the text, and sure enough, he said, can you come by tomorrow? And I said, yes. Anyway, now he's going to mail me the check. So, but I told him, I said, I can come by after 4 o'clock today, or I can come by any day on Saturdays. Let me know. I'll drop by. I don't care where I have to go. $700 check, you know. So anyway, that's how that goes. All right. But I usually get paid the day of the wedding, and I thought he was going to pay me the day of the wedding. So it's turned out to be a mess. All right, let's do another one. That was part A. Let's do this one. So again, they give you a graph. Let me try to draw the graph for you. This one might even be easier than what we just finished doing. This one goes from -6, 4. So -6, 1, 2, 3, 4. And it goes -1, 4 right there. And so this just goes from here to here. Yep, and they're closed circles on both ends, okay? But then this is piecewise, so there's a second part of it. It goes 2, 2, then 4, 2. So 2, 2, and then 4, 2. But, oops, this one is open right there, but it's also just straight across. All right, so here's the graph that they give us. Everybody got it? All right, so here's the closed circle. That one's the only open one. So I got to find the domain and range. That's what they ask for. So the domain and the range. We'll put the little brace, put x such that, it's not really that hard to put that fancy notation, is it? Just put x such that. Now, we got to look at them both. So where's the domain on this left part of the graph? From where to where? From here, which is at -6, to here, which is at what? -1. So there's -6, there's -1. X is between, less than or equal. Okay? Yeah, I put a or. That's what I was looking for. Or the domain is where? From here to here. So where is that? From 2 to 4. But what's the difference? So x is between, right? We can put a less than or equal because it's closed here. But what do we put right here on this one? Just a less than. That's right. We don't put a greater or equal because it's open. It's not or equal to 4. It's everything between 2 and 4. We good? Yeah, it's not so hard. After you did the first one, the next isn't so bad. All right, here's another one. Oh, we didn't do the range. What's the range on this one? What's the y value? Does it go from one point to the other? No, the y is just the same. All the way through here, the y is just the same. What is the y here? Y is 4. That's right. So again, we write it all fancy. We put y such that y equals 4, or what? Y equals 2. Actually, for the range, we should have put the 2 first, then the 4, because they always want to put it in chronological order, but I wouldn't mark it wrong. Oops, that's a weird brace. I wouldn't mark it wrong if you didn't do that. That's a little different than I wrote in the notes. In the notes, I just put 2, 4 instead of all that. I think that's what they did in the book, probably. Okay? All right, let's do one more. Come on. All right, now this one starts at -4, 6. -4, 1, 2, 3, 4, +6 starts here, -1, -3. It goes down to here. But this one's a curve, and it also goes to, what's that, 1, 1? But then it's open at 1, 1. All right, and then it goes to 5, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. And I believe it's closed. Nope, it's open there as well. No, they're closed. What am I thinking? Yeah, it's closed here, everywhere. Now, this one, it really doesn't make any difference. Really, if you just knew those points, then you could find the domain and range. But this one is a curve. So it curves like this until it gets to here, and then it's just linear. It's just a straight line from there to there. Weird looking graph, would you agree? And we don't have to figure out what the graph actually is. We just want to find the domain and range of this graph. So the domain, I'm going to put x such that. Now, where does the x? It goes to, starts here. It continues all the way through until where? Right there. So what's the domain of this? From -4 all the way to 5. So there's -4, there's 5, x is between. They're all solid dots, right? So it includes them all. So I put less than, equal, close the brace, and then you're good to go. Now it's starting to get pretty easy, isn't it? Starting to get the hang of it. What about the range? What's the lowest y value? This one right here. Where is that? It's at -3. So I'm going to go y such that it starts at -3. How high up does it go, the y? It goes up to here. How far is that? That's 6. Okay, so it goes to 6, and y is between. And there you go. There's a domain and range. So it didn't really get any more difficult, did it? It's just different shapes, different looks. Not too bad. When are we done here? 25? Yeah, there's no way we're going to finish this, but we can do one more. This time, they're not going to give you a graph. They're going to give you this stuff. Well, they're going to give you a little bit more than that. But they want you to graph. They're going to give you some, it's kind of like this. Okay, we're going to like redo this. It's just going to be a little bit more complicated. Not much, just a little bit. So you got 5 minutes. We can do this in 5 minutes. All right, so we're going to graph. Here it goes. It's basically like that first thing that we did. In fact, it's so much like it. Yeah, we'll just do it. I mean, it's in the book. This is example 2. Might as well do it. So I've got -3 if -5 less than or equal to x, which is less than -2. And then x plus 1 if -2 less than or equal to x less than 1. One more, -x plus 4 if 1 less than or equal to x, which is less than or equal to 4. All right, let's put the graph here. Come on, grab it. There he goes. Oh, missed it. Tack on it. There he goes. All right, here we go. We can do this pretty quick now, I think. Here's your restrictions. Let's graph it. So it's f of x equals -3, or y equals -3. So it's going to be a horizontal line, correct? But what's my restriction between what? -5, 1, 2, 3, 4, 5. So I can only go from here to where? To -2. So I'm going to graph a horizontal line that crosses through -3, but it only goes from here to here. So really, I'm going to do what? This is going to be open, and this one's going to be what? At -2. It's going to be closed. So just put a little line in between them, and that's the first part of my graph. Does that make sense? I don't go all the way across because I'm restricted between -5 and -2. -2 is open because it's not or equal. The -5 is closed because it's or equal. Make sense? Okay. Let's get rid of that little mess right there. There we go. All right, let's do the next one. F of x equals x plus 1. Well, what does that mean? It means we've got a y-intercept of 1 and then a slope of 1, right? 1 over 1. So my graph will go down like this. But I'm restricted between what x values? Between -2 and +1. Well, there's +1. It goes here. At -2, where's it going to go? It's going to go right here. Wouldn't that make a straight line? Yeah, if you wanted to, you could just put a -2 in for this. What's -2 plus 1? -1. So -2, -1. I'm not going to draw my line and with arrows on it. I'm not going to keep it going. I'm just going to go from there to there. So that's this part right there. Make sense? All right, what about this part? -x plus 4. Now again, I'm only going to go from 1 to 4, right? So let's go to 1. Let's actually do this. I kind of like what I did earlier. Put a 1 in for the x. So what do I get? -1 plus 4 is 3, right? So at 1, where do I go? 1, 2, 3. And it's closed, isn't it? Oh, by the way, I messed up on this. You didn't catch me. What's that? This should be open right here, shouldn't it? Okay. Nobody said anything. All right. I caught it. So there you go. You got that. And then put in a 4 for this. Negative 4 plus 4 is what? 0. So I go 4, 0, right? 1, 2, 3, 4. Would you agree? And then I just go from here to here. And there you go. Do they ask for the, yeah, they do. They ask for the domain of the whole thing. We started this on that first example we did. So let's find the domain and range of this whole entire thing. So put x such that, where does the x start? What's the furthest left that the x goes? To negative 5. You can even look up here and see it, can't you? Right? That's the smallest x value, so it goes from negative 5 to what? What's the biggest x value? 4. You can just look up here if you wanted to. Put a 4. So how do we write the rest of it? Put the x here. Now with the 5, does it include that? Yes, it does. Does it include the 4? Yes, it does. So less than or equal. So that's the domain. What about the range? The range is the y value. What's the smallest y value that we have here? Negative 3. What's the highest y value that we have? Positive 3, right? Everybody see that? Yeah. Let me double check, make sure. Yep. Positive 3. And this is, we include that. And we can include this as well. Even though that's open, everything else on here on the y value is closed, right? So it could include all that y value, so we include it. Oh. Oh. My fault. Messed up just a little bit. Hang on just a second. Watch this. I should have thought of that. There's a little gap between these. Agreed? Between this. So really there's two different ranges. There's the range for this one, and then there's the range for these two. So what would the range for this one be? It'd just be, now this would be negative 3. All right? And then the other one would go from negative 1 to positive 3. Everybody see that? So sorry about that. So that would be your domain and range. All right, I'm not going to give you any homework, okay, because we didn't finish the lesson. So you got the weekend off, isn't that nice? All right, and we'll finish this up on Monday.